We have a takeoff. Okay, so well, let's start with where we left, but we have our machines up and running. Our topics today, first of all, we are downloading AdventureWorks database, which is a Microsoft sample database having huge amount of data there to play with. So we're going to be doing some of the labs from this database now, although last time we tried to put our table, we tried to import our table from Excel, and we tried to create our tables, but still there were some features missing, like unique indexing was missing from there. We had to create our own. Actually, I had to dig out the internet for that. Then I thought, because I wanted to deviate from the usual book labs and going through this database, but now there are some features that require that we must have this database, which is pretty much very perfectly configured. Of course, it's from Microsoft. So many of the labs will be easily able to do and check the results after the discussion of concepts or talking about the concepts. So let's just attach this database now if you have downloaded already. And those who are watching the video, also please download that. And this is what we are going to be doing from now on till the end, and this database will be extensively used. So the error is there. The first file, don't go for the any other file, and we know that it's .mdf must be with .ldf or the log files as well. So that's what we're going to make sure that it has. But for that, so this is what it should look like when we are done successfully, and it's not a big deal, just attaching a database. So I'm just gonna go out of that and go back to this. So first of all, we have to copy that database inside anywhere in the SQL server. We have two SQL servers, right, and one DC machine. So I'm just going to copy this file on both of them. So at any time we're going to be trying to do this. So yeah, the file is 193 megabyte. Okay, so it's .mdf. You must have this file, and yeah, there is AdventureWorks 420 for all different versions as well, right? So this database has been configured with the features introduced in 2012 SQL and the other SQL servers. So I'm just gonna put this, I'll create a folder in C drive in both the virtual machines. New AdventureWorks. Why don't we just call it, Wonderland? Oh, okay. So I've just created a new folder in one of the SQL server. On the second SQL server, I'm going to put the same database file on a different path. So first SQL server, I created it in AdventureWorks, which is in the C drive, a new folder, and then I just pasted there. Later we're going to attach that. On second server, I just wanted to say show that hey, you can just put database anywhere, but proper way to do it is on the second SQL server. I'm just going for that path where the SQL server databases are available, other databases we have been working on. So the path we can put anywhere, but it doesn't matter when we try to do any exercises there. It's okay. So I'm just going for C drive for the second SQL server. You could, if you've just started one SQL server, it's okay. Just go for this second path. It's up to you, wherever you put. I'm just showing that both paths are okay. So I'm just going to C drive, program files, and then SQL server. And the version 11 is actually the SQL 2012. And then I think it's set up Bootstrap. Let me just confirm that. Okay, you know what, yeah, I forgot that. I was gonna just check the path from the started once. Yep, you're saying? Dot MDF. Oh, okay, you're letting me know. Okay, so let's just go to SQL Server 11. Taking over the minutes on the data. Let me just start that too. So on the second member server, I'm just trying to go to the MDF folder. So let me just start that at once as well, just to put the path on the video as well. Seriously. Okay. Starting one day it's going to. Okay, so I'm just connecting to the default instance and going for databases, right click or double click the database, or now I'm just going to any database and looking for the path. So if I go to any database, then go to files, then I can see that this is the path I created. I still wanted the path, so I'm just showing if somehow we are wondering, this is the path. So you were saying that exactly, but I just wanted to put in the video as well that program files, where to go if we are looking for a path, right? So program files, MS SQL Server, MS SQL 11, and the whole big name for the instance actually, but we can, and then the data, but this is just for this instance, and the main file is the data file, right? So on the second one, if we are going there, the data file is, if for me it's not showing, this means I did not create anything, seriously. So okay, for now I'll just not waste time and create a folder, and I think I did not configure it properly here on the second server. RAID volume, exactly, you're right. See, at this point I'm supposed to say, hey, I was just testing you, I knew that. No, I forgot that. So thank you. Now that's the fun part. Hey, I knew that. It's okay, I was just testing you. So okay, there it is, and thank you for this remembering. Yeah, I had too much coffee today, so normally my excuse is I didn't have coffee today. So okay, paste. So this is the usual path there. Well, that's about after 5 classes I'm touching this. Okay, so this is there. Let's just attach that. So I'm just going back to the first one, and if I go to databases here and right click the databases on the first one and second one, same thing, we just need to go there and to the proper path. The first one, attach. And then on the first one I put my own path, so click add there. Hey, I did mention in the email that the class is still at 8, right? Okay, maybe it was last night, so everyone's thinking class is starting at 9. Okay, so let's just go there. That's my DBS and not there, AdventureWorks. So this is the file in AdventureWorks, the root, the folder created in the root C. If I press OK here, it is selected here. Since there is no LDF for that, which is a must, if I press OK now, what will happen? So I added that here, the attached database say that, press OK, this error comes, right? So what we need to do is we just need to remove this LDF reference here, because it's saying, hey, I cannot find that and I'm looking for that, and I'm not going to let you go ahead until you tell me where it is. And while Microsoft did not create the LDF for that, what happens is that if we remove that and press OK, it's going to just create one for us, the LDF database for beside that .mdf. So I'm just going to click that and remove, and now press OK. So it accepts that, it has added it. If I go back to this folder where the database was created or pasted, now the log database is also present, right? And the above database is 200 megabyte or 193, and this is 504 KB. So the log files haven't started because we haven't started doing anything. So I'll just go to the second database, and this is the path for that. I'm just gonna, on the second database, that folder is still open. I will just click here and right click to copy the path so that I don't have to go that far. I'll just open the second one as well and simply just copy that. Let's go ahead. Here as well, the default instance, and then databases. Yeah, no database created yet, I guess. Okay, attach. Oh yeah, there were maybe different instances where I created those. So right click, attach on the second SQL server, and this time the path is the default one, so it is already opening at the default ones. In case it did not, I had copied that, so it is opening at the default ones anyway. Double click that or press OK, click and press OK. Same, it will same thing, just remove the reference of LDF as it's searching. So, and then press OK for the second one. Anyone left behind? Or okay, so it's nothing challenged so far, right? No challenges. Okay, so let's go ahead. We have our fully configured sample database downloaded and attached to our SQL environment on both SQL servers. Let's go ahead with what was left from the previous class and go for, so right click the databases. Yep, we did that, and yeah, we did not check, so just check that, expand that, and try to check all the tables are showing here, and there's a huge amount of tables there. So we're going to just go ahead now, and FileStream was what we discussed last time, but we're gonna just run some scripts on or some statements on this as well. FileStream enables SQL Server based applications to store unstructured data such as images. So the basic there are two uses of FileStream. One is that from within SQL, if you want to save any data, then you can use the Windows file system as well to secure or save any data from within the SQL. So administrators can use the FileStream feature to maybe place the data on a remote drive, remote disk, or on a SAN drive, or any remote storage, right? So there's one use for administrators, that from within SQL you can save data to some C drive, D drive, or any Windows file system. The second thing is that you can make available FileStream feature for other users to actually save data through SQL to any of the drives, and from the drives it is fully secured, or it is committed to the database as well. So other users can use the FileStream as well as, but it's like, if you try to really go deep down into checking it, it's going to be really tough. Even in the book, which is for the exam, they have configured the server-side features. I'm going to send you the lab for client-side testing, and that's like if you're in a production environment, you should try that. Otherwise, FileStream in some companies it's not enabled, but majority of the companies it is enabled, and they are using for either just for administrators, or they are offering this feature for the users to actually save the data as well. So to use FileStream, you must create or modify a database to host a special type of file group. So we're going to talk about file group as well. What is it, where is it located, and how to create that from statement or SQL statements, as well as from in the GUI. So after which, so we're going to create a file group, after which you can create or modify tables so that they can use the var binary max column with the file stream attribute. Anyway, what it's saying is that if you create a file stream, you have to create a file group for that, and then you have to create a file. If I just put it on the most sophisticated software of all times, Paintbrush, so it's going to be just file stream. We have to enable the file stream so the database will be able to offer file and so non-binary files or unstructured data, which is just, I can just say movie files or song files. We would understand very easily that way. So file stream first is configured, then oops, wrong one, oops, again wrong. So, and then it's the file groups that we're going to create. Then we're going to create file. So I'm just going to expand that. And then we're going to create we're going to just give the path of the directory on the C drive, D drive, right? So if this is the structure if this structure is configured properly, we're going to be able to offer the file streaming and it's this streaming terminology cannot be used for this. This is not streaming, it's just file stream. So we're just used to having the streaming thing, so it's just file stream, not file streaming. Okay, anyway, so let's go ahead and try to configure that. So this is going to get a little tricky or confusing. That's why I'm just saying that first we have to configure this, then this, then this, then this. So I'm just going to go step by step, but for that, let's just exhaust all the information about that. So file stream enables SQL Server based applications to store unstructured. Yeah, we did that. Okay, let's go ahead. You should use file stream under the following conditions. One is objects that you want to store are greater than 1 megabyte. The traditional variable binary or max limit of 2 GB does not apply to blob. Okay. Hey, which movie did you hear this word? Blob. No way. So nobody's Ghostbusters, right? Okay. That was like, way old. I'm not that old, right? Okay. Anyway, so blob does not apply, but blob just means that large file placed remotely. So overall, it just means that. So binary large objects stored in the file system. So there is a 2 gigs of limit which we can remove, so we can store in the SQL Server bigger than 2 gigs of files as well. So we just need to run a query for that, and it's going to remove that limitation of, hey, we cannot store more than 2 gigs, so we can store even bigger files. It's just that database will grow crazy if you enable that, unless your CEO says that, and you need to save your job. So that's purely political. Anyway, there are many scenarios for that, that you want to save those kind of files in the SQL Server. Fast read access is important. Yeah, you have to have fast read access. So RAID 1 is good for that. If the hard disks are smaller and they are SSDs, of course. So I'll just go ahead. So first thing, we have to enable the file stream from here. So anyone knows what is this console? Where do we go to access this console? Good, that's good. Anyone else? Yeah. No, nobody replied. You ruined all the fun. Yeah, exactly. That's it. Thank you. No, I'm just kidding. Okay. Okay, Configuration Manager, exactly. Thank you. And so where do I go for that, since I have a couple of million applications open here? So yeah, just going back to configuration manager. So I'm just gonna go down to this area and go for SQL Server. Let's just type there config reporting services SQL Server configuration manager. So if you're looking, this is a red box, just go for that. Otherwise, just config, just type there in this search. Press yes. So exactly, configuration manager, and in my case, or in our case, of course, we all install a lot of instances, so lots of those are showing here. So I'm just gonna, since I just am trying to, I attached this database to the default instance. So, wow, it's pretty clear from here. Wow, okay, not. Oh, how much was it? 200. So, which instance is the one I should be working with right now? Yeah, MS SQL Server would be the default instance, right? So we did install all the other instances because we were installing the analysis services, and we just went for separate instances instead of the default, just to get the statement or the query, just to test this query if it is working. Then we could have gone for the default ones. So this is the MS SQL Server, and this will be the one where we're gonna make the change. Those were just the extra services, full text indexing, and so SQL Server itself with MS SQL will be the main. This will be the area where we're gonna make changes for the file stream. So SQL Server properties and file stream. So we're just gonna go ahead and enable that for all three options here. Enable file stream for transact SQL, so we could run queries as well. Enable file stream for file IO access, and allow remote clients access to file stream data. So IO access as well. So from GUI also we can use this feature as well and configure it. So the only thing I did was that apply. Okay, let me just go back there after applying. Okay, is I went to configuration manager and then SQL Server here, right click, properties, and file stream, right? So let's go ahead and do the next configuration there. Okay, over there. Am I going too fast or too slow? Or okay, next. Let's go ahead and first thing is configured. Second is yeah, that's what we just did. Open to enable file stream. That's where we need to go and do this. You can also use this dialog box to enable. Yeah, we enable that IO streaming as well, access, and to allow remote clients. Let's go ahead and so this. Okay, let me show first what it will achieve. This statement, SQL statement, will be so setting file stream access level to 0 disables file stream access. So it was 0. Setting level 1 allows transact SQL, so only queries can be run. Setting level 2, which we're going to set, allows transact SQL and GUI or Win32 streaming as well. So excuse me. So this is the statement, and are we all on that site? Let's go to that site. When I say that site, so let me just put that. This one, notepad.pw, right? And I did send the path before. I'm just going to send that again because that's where I was, sharing all the codes. So I'm just, okay, so I'm just gonna send this link again. Notepad dot, oh, that's pw, sharing today's codes here please open. Okay, so Control A, Control V, Control A, send. Okay, so I'll send that site again. So I'm just gonna put this code there, and what this does is gives us the access to file to use the FileStream feature. So I'm going to that. The previous codes are also there. So today's date, so 08 Feb 2016, and code for this to let us use. So you can refresh that page and you can see and copy the code while I'm just writing the explanation or definition for that to let us use the FileStream. Yep. Oh yes, and previous ones, yeah, we don't need to. If you have not saved it, this is the time. And 3, 2, 1, gone. Did you save it? Anyway, it is in there. Do you want to save it?
No, I meant like.
Yeah. Oh, okay.
I meant just like put the new stuff on top of the old stuff so the old stuff archived.
Yeah, right. You know, this is accessible at any time to anyone, and anyone can edit that as well. So anyone can put a nice code that if we run can actually crash the SQL. Me and my big ideas. Why am I even saying that? Okay, anyway. So let's not delete that as well. You're right. So this is a very good convenient. This is a convenient sync. So let's just put that code and start putting the rest. I'm just going to put that down and put a date here as well. What was the last one? Since somebody just stumbles on this one. Okay, so this will just let us use this, but before using that, I want to go to one area and show you that if I go back to the SQL Server before running this statement, this command, so if I go to any of the databases, this command is not talking about specific. Okay, if you go exact, nope. It's just opening the FileStream, right? It's not asking for, or whichever the current database or instance we are working for, any database for that instance. If I go to any first database, food, and right click properties, and go to FileGroups. So let's just see or keep in mind that we need to see this area also enabled, right? Because we're going to be configuring this. So I'm just checking one more database here, AdventureWorks, or any one of those 4. Going to the same right click properties and then going to the file groups. So this area is disabled. The below one, the FileStream, and there is one file group configured right now. We're going to be talking about file group as well. I'm going to create some, and okay, so just checking randomly one more. Okay, and once we make that change of FileStream, clicking it open, we're supposed to actually restart the instance or the server. But before that, let's run this command, and then we at least get to know that did that command do the stuff before even starting, because there was some testing I did. So this command was doing that, but still we have to restart later as well. When you open FileStream, you have to restart the services, right? So for now, I just clicked the database and went to the new query, and let's just copy paste and run it. So copy, paste. Okay, and I'll just close this one. For now, I don't need that. Control A, F5. So configuration option, FileStream access level, change from 0 to 2. Run the reconfigure statement to install. Yeah, let's just without restarting, let's check that. if any of the database is showing. So I'm just going to go back to any of the database after pasting that. Okay, yeah, this area is open now. So I just wanted to check the second one as well, because this is instance level file groups. Yeah, all the databases have this lower area for further configuration of FileStream as well. Open after letting us give permission. We're just opening this file group area to let the FileStream part of the configuration work. Okay, let's go ahead, and yes, we still have to restart after doing this. So we just ran this statement, and let's just restart this now. No one got the error, right? Yeah, so far so good. Oh. Okay, so let's just restart this, and it's the SQL Server, and right click the top, and the default instance is only loaded. So we're just restarting this. Press yes. Are you sure you want to restart? Obviously, if there were connections to the food, lunch, test database, AdventureWorks, those all connections would have been disconnected, of course. We do not do that just like this, so you have to be very careful about that if anyone is connected or not. So let's just go ahead and check the next command. So what we did, we gave access to ourselves to configure FileStream, and we made sure it is enabled. Although restart should have been done from within the configuration manager because it's through the SQL, but we still were restarting from within the SQL and not going directly to the services.msc. You may have remember that, that's the Windows services that we can restart. Okay, creating a FileStream file group. So as I put that, first we enabled the FileStream, we gave ourselves the access. Then now we are creating a file group within the FileStream. It is just compulsory that if you want it to work, this is the way we have to make it work. We have to start enabling and adding more stuff to that. So create a FileStream file group for the database. For example, to create a FileStream file group, we're going to be talking about file group just later today. So FileStream file group named. So we're going to be creating a file group by this name for this database, and this is the syntax for or the command for that. So we could change this to any name, or we could change it to any 4 of the databases, right? Because we have access to configure FileStream. So I'm just going to put this code there online so you could share that. Okay, it's there. So, and this is creating file group for FileStream config. Okay. Are you able to control B this? No, it's not that much. Okay. So let's just run that. So it's going to create this in the food database. This means we're just trying to use the FileStream configuration in the food database, or whichever database you want to put it on, right? So I'm just going to copy that and go back and paste it and just run it. So in the same page, just press one more enter, paste that code again. File group will be added to food database by the name of FileStream file group. That's all we're doing. Contains FileStream. Yep. So just select this one and execute or press F5. And there you go. Transfer error has occurred when sending the request to the server. Provide shared memory provider. Anyone else got that error? We all got it. Yay. What? Really? Okay. So we can use master, go alter database, food, add file group. So if I go to food and properties and file group, We can just change this. Contains file stream. Okay, when I go back to the slide, because I, yep.
It works, you just don't select. You select the older database, start from there.
If you don't select the alter database,
Yeah, don't select use master data. Just select this
last two lines. Well, we are supposed to. We always to use that. We are supposed to, but anyway, if it works, but it does work always. Hey, that's good that you're testing other ways as well. But if we don't include that, it's not going to.
If you put in just a separate query by itself, execute it if it works.
Separate query?
Yeah.
What do you mean by that? So new query?
I didn't have that first
Yeah.
figure one.
The top one.
Yeah.
Okay. No, I just, if you just select that,
It only runs the line.
yeah, it.
Well, even when I highlighted, I got that error, so I don't know why it worked the other way.
You know, there's that communication as well. If I just minimize that, although it should not be related to that. So, okay, if I go for copy and go for new query here, new query, we can just add any amount of queries, right? So, oops, use master. It's still giving the error? Oh, okay. Because it connected this with the older one. And, oh, did I just select that? Now it should if I just execute this again, it should say already exists. Oh, you know, maybe I selected it this way because it's connected that to this, right? Sorry? No, it's not on master database, but it is using that as a model. Like it just goes through that master database, which is created here in system databases, right? Within system database, there's a master, there's a model, there's tempdb. So it always is supposed to use this one as sample or use its configuration, basic configuration to make amendments. Okay, so this is executed. Okay, different experiences, but try to not use the whole thing. The use master, then go. Okay, let's go ahead and try to see if it created this in the food database. So if I just right click that now without refreshing even, so yep, so FileStream file group, we could have just done it through graphical interface anyway, but hey, for majority of us the class will be starting in 3 minutes anyway. So okay, because by this time people are like yawning and entering, and so it's kind of fun. Class becomes lively. It's already lively actually. So FileStream is enabled here and default. What happens here is that whatever files are, well, we haven't fully done configured it, but it's going to, whenever we are to save a file through a SQL script actually, so it's going to check for the file stream configuration, then the file stream that inside the file group it has the file stream. Does the file stream have a file group? Then next thing we're going to create, let's just go ahead and let's make sure in the slide we don't miss anything, because it's all step by step. File group is created with this. If I go ahead a little, add file stream files to the file stream group, now the bigger code is coming where we are defining a file and a path. So let me just show you there. If I could do it graphical interface as well. So in file group we created a file group with this name under the file stream. Then we are supposed to go to the above one, which is files, right? Don't do it now because we're going to do it with the query, right? SQL query. We can create a file that we will attach to this file group we created, we're going to do that with the SQL query, but we could have just gone here and clicked add, and it would just ask which file and which file group you want to connect to, right? But I'm just not going to do that now from here. But this is the next path, and from this file we need to also define where is the C drive where ultimately the data will be saved. So I'm just going to start the next code, and this is the end of the most important lab of all times. Okay, so, and you missed that lab, that was so important. No, I'm just kidding. Okay, so but that's fun, you know, somebody walks in and I missed it now. You're still making a video anyway. So another, okay, anyway, so this is the next code. I'm just gonna put it there. What we are doing is we've enabled FileStream, we have created a file group for that. Now we're going to define the path in C drive where all the files are supposed to be saved through a file. So I'm just gonna go through that again. Let's just create that structure, and I'm just gonna copy that now. Let's see if there's no spell mistake, or when we copy paste there's a comma, inverted commas that you know, get so inverted commas that are, you know, changed sometimes. So I'm just gonna put it on the site as well. Now this will, okay, code is there, you can just use it now. I'm just putting that explanation here. Now we define a file for the file group and the path on C drive. I think I should differentiate it with okay, so let's just run that code, but so it's going to create in the food database, add file, FileStream. So the file name will be FileStream file. The path on the C drive, the folder it's going to create will be this. So we're gonna, if you run this file, just double check if the FSTRM folder has been created in the root of the C drive, right? So I'm just gonna go there now, copy, and so okay, path. Are we missing something here? I think that's the, oh yeah, it's that exact thing that happened before. And okay, yeah, so it does not show that wavy line or waves. Okay, execute successfully. So now I'm gonna make sure, did it create a folder and did it create a file for the food database as well. So coming from above, we gave ourselves access for the file stream, we enabled it, then we created a file group by this name, then we created a file and a local folder for that, right? So properties. So this is the end of that very important lab we were doing. Okay, it's no longer funny. Yeah, I understand. So you guys missed a very important lab. Come on. No, I'm just kidding. Okay, files. So it is FileStream has been created here, right? And file type, FileStream data, right? So file type is FileStream data. So we are just putting there, and then unlimited, and the path. Hey, it's just C drive, right? So file is created for this file group, and press OK, and let's just go to the Windows folder in the C drive, yes, it has created that folder as well, FileStream. We're just checking all those areas just for the basic configuration of the file stream. Oh, seriously? Yeah, so there's a misunderstanding that the class is starting at 9, right? So I did put it way back that it's still 8 last night. So it was last night I put it on the email. Hey, do we have a WhatsApp group? Do you have a WhatsApp group? No? You guys are not organized at all. All other sections, classes, they have WhatsApp group. So, you know. So it's not. It's still 8. Sorry. Yeah.
Within this management studio, you know when you're inputting your query, is there a way to make it work so you have to scroll?
Oh, okay. So it's like word warp.
Yeah.
There. Well, we can just go there and check, but I didn't do that before. I didn't have to. But this would be useful if we could just figure that out. So we can just go to Tools, Options, Text Editor. This is where you can just, you know, search for all those text editor. So Tools, Options, and then Text Editor. And it's all our preferences, what we want, how we want to see the editor. And there you go. There it is. WordWrap. So I never tried to do that because I didn't require, but definitely this is good to know that WordWrap is there and should be there for text editors. Show visual, wow, glyphs for WordWrap. Okay, this is a new word in dictionary, IT and English. Glyphs. All right. Anyone already heard that? Glyph? No. Okay. So, anyway, if you just put that there, that's going to be good as well. Good. Okay, thanks for this. Let's just go ahead and what we did: file stream, file group, file, and that folder in the C drive. So let's go ahead a little and check out. Yes. So what we are trying to make sure that FileStream folder is created here. So configuring file tables, that's the next stage. Once we are done with the file stream configuration, then we can create the file tables. The purpose of the file stream was, again, it was to to facilitate saving of files bigger than 2 GB, as well as to save through the SQL server, as well as for the clients to give a link to save inside the SQL server. There is the testing of this. There's a script for that. So I'm gonna be sending you the script, and maybe I just put it in the midterm as well. But I'm just gonna try to make it less horrible for you, the midterm. This is a setting from the server side. When we try to check the client side, it's going to be tough. So I'm going to be sending a script to run. If I start doing it now, we will just, we won't be able to go for other topics then, because it's a bigger script. I'm going to revisit this topic for file streaming as well as the file groups. And then we're going to learn a little more about, because we don't know yet what is file group. And once we go through the later topics, then we can come back and do this as well. Or in a later class, I'm going to be running that script for you, right? For now, server-side configuration we have done. Server-side configuration. But and this is what the book has also done. Normally I go with the book, but for this, the time-consuming script, I did not want it to configure right now or run it here. It's going to give us a lot of problems because it gave me a lot just in practice. So what is configuring file tables? Oh, that's okay, wrong choice. File tables are a special type of table that enables you to store files and documents within SQL Server. Okay, yeah. Still, it has we have to still configure file streaming for configuring, in order to use file tables. The basic concept is still the same. And okay, wrong choice again. These files and documents can be accessed from Windows applications. So there was that option that from FileStream we can manually save the files, but when you configure file tables, the Windows applications, once connected with the SQL server, can use this file table to save all the data that application automatically can save. So that's the difference between when we configure FileStream and when we configure extra file tables as well, that applications, Windows applications only, well, it could be others as well, Windows applications, once connected, can actually save files in the SQL server as well automatically. So for example, you can add files and folders to the file table by dragging and dropping them in Windows Explorer. Yeah, they just present it so, with simple sentences. When you start doing the lab, it's, you just grab your head and like scream, what? Why can't I just save it somewhere else instead of SQL? Why do you want to save movies and songs or, big documents there when you have encrypted file servers to do that stuff? I did not see that SQL Server is being used for other files, bigger files. But okay, so you can remove them from the file table by using the same method as well. So we can just drag and drop any of the files if we have configured properly the file tables, and Windows applications can use that automatically to save data, right? The file table provides the following functionality. Hierarchy of files and directories, it can show that. Yeah, Windows Explorer can also do that. Each row, but it's rows and columns now. So each row in a file table represents a file or directory, and each row holds the following items. A file stream column, so there will be these columns that we're going to check, and the GUID. What is GUID? Anyone knows that? Nobody Googled till now? Oh, GUID is globally unique identifier, right? So it's the cousin of SID, security identifier, right? Cousin, distant cousin, we can. Okay, so anyway, this is also with the when you create an object in the Active Directory, GUIDs are also assigned. The new machines that are deployed from any vendor, they assign also GUIDs to the hardware as well. It's a globally unique identifier, a long alphanumeric number that should be unique for this machine across the globe. Wow. Okay, so path locator and parent path locator columns. So whatever file you will be putting there in SQL will be assigned a GUID. And 10 file attributes. These include creation data and modification date. Type column that supports full text and semantic search. We did talk about semantic search. What was semantic search? Anyone knows that? Semantic antivirus you might have used, so it's not related to that. Yeah. Okay. Semantic search is that if you're looking for a search word inside the SQL table, and if you have put it wrong spellings, then it's going to intelligently, just like Google says, oh, did you mean that? And majority of the time, 99%, we do mean that. Okay, not in my case, 99%, but in other case, So anyway, it's just like that, but no, it doesn't exactly work like that. It just searches the most relevant word if you have typed it wrong. In fact, when we configured the full text indexing for a table, we should have checked this as well. But we needed a bigger table to do some intelligent searching, or at least test some searching that does it do that even or not. So now we have AdventureWorks. So if you check, everyone, if you check your those who arrived at 9 o'clock or near that, so you can check your Google Mail. I have sent a link to download a database that is 200 megabytes. before the whole college starts streaming videos. Before that, just download that. It's going to take a lot of time later. So download that database and attach it. So there will be a break, and I can help you attach that database as well. So the file table will contain all these features to search, as well as assigning GUID to the files that you're going to be saving in this SQL server, and just creating columns to organize the whole thing. To enable file tables, perform the following steps. And there comes another. Okay, enable FileStream at the instance level. We did that already. Enable FileStream at instance level, already done. Then you can do this for an existing database by using the alter database statement with the sets FileStream option, for example. And this is the code that I'm going to. So what we are doing is, we have already created that structure of that file stream, file group, file name, and then the folder. We just need to enable the feature of file tables for that folder as well. So I'm just putting this code there, and to enable file tables, I'm just going to put that information there. So, and then we're going to I'm going to show you where to go and check that if this feature is also enabled for the food database. So putting that on the net. Okay, it's there. Enabling the same file stream folder with file table feature. Okay, so make sure if you did not put the same name, folder name, change it to the name of the folder you put there, if it was not that folder name, right? Your question, or you're yawning? Oh, okay. It's always confusing. Yeah. Whenever we yawn, oh, okay. So, if you will get an error if the folder name is not the same. If it's the same, then this. Otherwise, just put your folder name, whatever you put there in C drive, or when in the last statement, if you change it. So I'm just gonna copy that. Oh, it's already copied actually. So just go there, check. I'll just create some more space here. Down. Paste. Oh, seriously. How is it related? Anyway, should not give me a problem. So select, execute. Okay, successfully. So where do we need to check if the file table feature has also been configured? If I go to the food database, because this is the database we are still, punching, or okay. So I'm just gonna, after running this successfully, this. Anyone got an error with this? No, right? All good. So this statement there. Let's just check what it did. So food, right click the database, properties. In the files, in the options area. So in the options area, here the file stream, the directory name is now created. What is the meaning of non-transacted access? Non-transacted access. So I just put it there. So I right click food, then properties, then went to options. So this is the area what it changed. In fact, I should have just gone before that when it was not populated, or it was just putting directory name, and then I should have gone, shown here that hey, this is the change it made. What it's doing is here that this is the folder that we created. This means that whatever files will be transferred or saved, use this folder to do that. And non-transacted access just means that any Windows applications once connected to the SQL server can save data on this path. That's what it means, right? Any Windows applications can, if one's connected to the SQL server, can save its data on this path. So pressing OK, alter database, set FileStream, non-transacted. Yeah, this is a non-transacted access, full, and directory name FileStream. So still we're working ahead to put the to further configure the FileStream, which is used. This feature is used to save all the bigger data inside the SQL server if you choose to do so. Let's just go ahead and check what other features we can enable for file streaming, and then expect that script and some instructions to actually run and test this file streaming, and just put a proof there. Hey, I made it. If I want to save this file, this is the way we can. So let's see how can you do something on your own, and I'm sure you can do it easily. So let's just go there. Yep, that's where we try to check FileStream. To create a file table by using SQL Server Management Studio, right-click the Tables node and choose New File Table to open a new script window that contains a template transact SQL script that you can modify. So if we wanted to check many of the options that a ready-made script for creating a new file table offers, so if I just go out and go back here, we used this script or this command to configure the file table, but we can just go to food. Suppose if we go down inside the food and inside the tables area, we created one table called employees. You may remember I think we imported this from, no, we actually created that script in the last class. I just put it there on the site and then put that. So this is one table that is created there. So there is a difference between this new table and file table. Can anyone tell me, can you guess what is this? What is the basic difference between a simple table, which we have been, we've been created the type older tables. One table was for George Brown students. One table was for employees. Now we're creating a file table. Well, the name says it all, but anyway, anyone wants to guess or tell me what's the difference? And the other table, so yes, file table saves files, exactly. What's the difference between the two tables? If I want to create the other one, it's going to help me do what? The first one, the table. Okay, that's so obvious actually that you don't have to answer that. It's okay, because it's just going to. Anyone can still give me that one word that I'm going to tell anyway. What's the difference? Because anyone else did not raise hands. This means this is confusing. I gotcha there now, right? Because it's so simple, you should be telling. So file table, it saves files. An example is songs, videos, or anything. What is this table we've been working on since we started the course? What is it saving? Is it saving files? It's just saving data. So the difference is the data and the files, right? So this is the normal data. It's going to save the normal data, and the other will just save the files. But we should not, confuse. So we are creating a new table. Just don't go for in the test for a file table when you're expected to create a table, right? And that's the difference. That's why I just took a little time. That if you go ahead with the second one, if I right-click the new file table, it's just giving us a template to edit, right? So this template will have all those options that we already configured through that if the options which I was telling you, if I right click the food, go to properties and go to options, FileStream related, so directory name, what directory name that you want to save the files on, we already have that. If you go to the C drive, we already created that. This is the one. If I double click that and go inside, so if I'm in C drive, FSTRM, and when I double click, it's going to ask me a permission for the local administrator. So it has created a log folder and a FileStream.hdr file. That's just tracking what files will be inside once you have created a file. I'm gonna send you the script and let's see how you come up with that to actually save the file here, right? There will be errors, so you could just contact me or Google, contact our master Google. This is what we already did, although it has, you can just specify the names as well. There's AdventureWorks already present here that it's going to make changes in that table, but we can change the table as well, and we can just change the path as well there if it is totally new file table. So just showing that when you go for new file table, it's just going to show us our template. While we are creating this new table, it's just going to let us create a actual data table, right? So that's the difference. We did do FileStream configuration. That's why the file table template is not what we're going to go through, but we get to know that at least, okay, there's a template for new file table if we ever wanted to configure that. So designing and managing file groups. We have been talking about file groups, but we didn't discuss what is it. We've been putting it in our queries, but what is it? So each database has a primary file group. There is file table, we already know that, okay, it is used to save files, but we didn't actually test it. So client-side testing, without that, of course, our production configuration is never complete. In the book, of course, it just goes to the server-side testing and, hey, I showed you the option, that's it, I'm done. I would love to go for the client-side testing always for most of the labs. This is one of those there where I'm just gonna send you the script or perform it at later time when we have a little more time for we have covered majority of the topics. Okay, so each database has a primary file group. This file group hosts the primary data file and any secondary files that you have not allocated to other file groups. So let me just explain that in that paintbrush. So when you create, okay, this is a SQL server, and inside the SQL server you have a database called food. And inside the database, so you have the file called food.mdf. This is the master file, master database file, right? And you also have food underscore. Do you know that what file is most important that is supposed to be created beside the .mdf file? Anyone knows that? Whenever we create a .mdf, we have to create this one. LDF, exactly. The log underscore log dot LDF. There's a third one. We did talk about that, but we not in detail. Anyone already knows what's the third one? Third type that we can still create, which is I just go for food.ndf. It's called the secondary database file. So this is the file we can have. Okay, food.ndf. Then we can have actually food1.ndf. We can have food2.ndf. We can have lots of ndf files which are just helping the mdf file. And what they do is whatever data you're putting on in the database, all the data is initially, of course, if you do not define the NDF files, all the data is going inside the MDF file, master database file. But once you define file groups, you can tell that from now on, whatever data is coming to this database, one of the file groups responsibility is that it can spread that data between this and these helper databases, right, or the secondary databases that are related to MDF. So the only purpose here is that whatever data is coming should not be only coming to the MDF. It can spread out to .ndfs as well, and it's going to give a relief to the read and write operations being done on MDF database alone. So file groups help distribute or divide the data or load balance between just the MDF. Instead of MDS, it's going to save the files, or we can configure through file groups to save the file or spread the files across several databases instead of putting pressure only on one .mdf file, right? Right or wrong? Oh, okay. So this is going to spread. So now we're going to try to learn that how through file group we can spread the data between different secondary databases, or how we can create separate file groups. And actually also, if file group is created, file group, so it can help save data on different drives. Oh, seriously. So this is what we want to know. File group, it can help save data on different drives. Can you tell me what's the benefit of saving data on different drives? It's supposed to be saved. If you don't define file groups, it's going to save on MDF. MDF is on one drive. If it is spread on separate drives, what's the benefit? Speed as well as speed is, so there's read and write is being used for separate disks. Spindles are used for whatever data is on the separate disk exactly. Performance is the best option, as well as sorry? Yeah, exactly. So it is safer if you lose a drive in any case, you don't lose the file as well, which is saved there. You can still recover it, which is on a separate hard disk, but mainly performance. Okay, so let's go ahead and try to configure file groups and see how does it really work. Each database has a primary file group. Yeah, we went through that. This file group hosts the primary data file and any secondary files that you have not allocated to other file groups. The system tables are hosted in the primary file group. So there's a primary file group, and then there will be secondary file groups as well. Let's just go there and check. You can create file groups to host data files together for reasons including data allocation, administrative, and placement. You can just place, or spread out the data on different drives, still the main purpose. Secondary data files use the .ndf extension, right? So this means you're spreading the data from, or you're taking away the pressure of performance from MDF and relieving it from that pressure, so it could perform well with less amount of data by spreading the data between .mdf and .ndf files, right? So you can assign these secondary files to different file groups. We're going to do that now. Secondary data files that are hosted on different volumes can be assigned to the same file group. So one file group can expand or span between 4 drives. One file group can spread the data between 2, 3, 4, 5, 6 drives. It just is how we configure it. So we're gonna just configure now and try to see its features. When you create a table or an index, you can configure it to use a specific file group. So we're going to create a table now, and we're going to try to use a specific file group. When a file group contains more than one file, the database engine will write data across the files proportionally, depending on how much free space is available in each file. So we can define different file groups. Actually, this is too much theory. Let's just try to do that. Okay, next screen. So we are creating a file group, and this is the code for that. Inside the food database, we are creating a file group called accounts and a file group called management. So for that food company, there are accounts department and management department, right? What is the scenario? The scenario is that if we create these two file groups, we can assign them different drives. So the data what is coming from for the food database will be divided between the MDF and can be also redirected to accounts file group as well as management file group, distributing the data. So let's try to do that and try to understand what it really can do. So I'm just gonna put that code up there on the cloud. Wow, hey, we can use that term now. I'm putting the data on cloud. So okay, again on internet. So let's just okay, it's pasted, and the purpose is to create 2 file groups to help relieve performance pressure from .mdf master database. Wow, that's a long definition. Anyway, so okay, there's the code. It's going to create 2 file groups. Let's see if it did create that. So I'm just going to copy that and go inside. We could just have 6 file groups, right? Okay, so close this, and yeah, this is a script for template for the file table. So I'm just going to, yeah, I was putting all the queries here. I'll just keep messing up by just wanted to see if I could just use a whole page and not mess up with several queries. Okay, it's still regarding the same database, so it's connected. I'm just gonna select all that and execute or press F5. Command completed successfully, but what have we done by this running this query? So if you go to food database, anyone got an error for this? Nope. Okay. So if you go to the food database now, guys who are reaching after 1 hour or 1.5 hours, they can also join any of the lab because they're all independent labs. It's not like if I started at 8 o'clock, the next lab depends on the previous lab. Okay, today's lab, yes, but most of the labs, they're not, right? FileStream, you have to configure FileStream to see that. But this one is an independent one. I mean, creating file groups, it has nothing to do with our previous labs, so you could even join now and do not feel that, oh, I'm left out because I was late. Okay, don't feel that, right? You can just join this lab or any of the independent labs, and we here to mess up our databases to actually learn something from there. So don't try to keep it clean, stay without any errors or anything. Just try to do all the things, test all the things, so we get learned in that. While doing that, if we mess up the database, it's okay, recreate Okay, where are they created? So if I go to food database properties and go to file groups, there are two file groups created, right? So primary means that primary is the default file group for each database that is created. There's a primary file group created, and primary just means that through this the data will be saved inside the database, the primary. But we have just created two extra file groups. What do we do with them? What do we do? It's like Scooby-Doo. Okay. Hey, anybody like Scooby-Doo? No. Yes? Come on. Okay, anyway, so am I talking old things? I should be talking about Transformers? No, that's also old, right? I don't know what's new today. Okay, so let's just go and so first thing about this, let me just create that in the most sophisticated tool of all times. Then I say paintbrush. Okay, so file group, once it is created, then we need to create files which can connect to file groups. Groups and can be placed on separate drives. So file groups can be connected or have to be connected to the files. Let's just try to see that when we connect this, then we will totally understand, oh, this is file group, okay, because we haven't done the file portion of that file group. So let's just go back there. I'll just first go back to the slide. So all the data is automatically saved to the primary file group, but we can create a new table and add it to the second file group. We could have created it with graphical interface with click add, but going with statements is, let's create files for those file groups. Now we have created accounts file group, we have created management file group. So correspondingly, we have to go to the files area, we have to create accounts file, and we have to connect this file to the file group called accounts. Then we have to create a management here, a file, and we have to connect this file to the file group called management. And we're going to see why, because there should be a path showing here as well. That means that they are part of the same database, but the data can be saved. A table can be saved on any of these file groups which are placed on different hard disks, right? So let's just go there and do it on the GUI side by clicking. So I'm just gonna go to the files. File groups are created, right? So going to the files and then clicking add. We already created a file group called accounts. Now we just need to connect it to the file and connect it to the, we have to create a file and connect it to the file group. So accounts, once we create a file called accounts, and then there are two file groups that we created. So accounts file will be connected to a file group called accounts, right? And then again, second file I'm going to create now. If I click add again, we created another file group called management. So I'm just creating a file for that management and connecting it to the file group called management. So should there be two NDF files created for that same database apart from the MDF file, which is the master database file? Should there be two NDF files? N DF files. So what was the difference between the MDF and NDF files?
NDF for secondary.
Yeah, secondary databases. And the main purpose, one-liner purpose was to. Yes, you're right. Yeah. Anyone else? Oh, okay. Purpose was NDF is used for dividing the data between MDF and NDF. NDF is just a helper database. That is just there. Hey, MDF, if you have a lot of pressure of data, you can just give some data to me and I'll save it and I'll help in input output for data. I'm your helper from now on today, and I am the NDF, right? So if we do not create NDF, MDF will take all the data and all the input output will be done on MDF on one hard disk. One hard disk will do the inputs outputs. So NDF is a helper database that is just helping the MDF, right? So each MDF can have several NDFs. So how do we confirm that we have helper databases now available with master database? Okay, let me check that. If I go to food and go to properties here and go to files, you can see here. So I wanted to confirm that. So if I go back to the files now, so last time we pressed OK and everything. So if now we go back to the accounts file and management file, let's just check the accounts file first. If I scroll to the right side for the accounts file, you can see here accounts.ndf has been created, right? And if you go to the management.ndf has been created, and they are on the same path as the master database file, that main file which takes on all the data for that particular database. Now these are the helper files .ndf where we can spread the main data into these files if we wanted to. Or if we want to create a new table, we can actually define that, hey, I want to create that table inside management.ndf inside the food database, and file group should be management.ndf. Don't pressure or don't put files on MDF or master database every time. For this table and all the queries I'm going to run, the helper database will help me, and the performance pressure will not be put on the master database. Let's try to do that as well. So yes, 2 NDF files have been created when we created 2 file groups and attached them with the files. So now there are 2 helper databases for the master database file. Okay, so let's just check out the slide, because when we create a new table, are we able to define that, hey, I want to create this new table in the NDF or the helper database, not in the master database file. So if we go, each file group is showing one file here. So each file group showing one file each, and we can add more files to which we can add data. All data goes to the default file group, and if read only, then has no data writing in it. We have not put it on read only yet, so this means the data can go there and be distributed. If we put read only, then this cannot be used, right? This NDF file cannot be used if we put it on read only, but now it can be used. So let's try one of those. Let's create a new table and try to connect it to any of these 2 file groups instead of the primary where it automatically connects. So if we have a very huge table which has so many, thousands of rows and columns, and we connect it to the primary database. That's one table for a hospital. Then you create another table, and that's also having huge amount of rows and about all the patients that are coming. And for second hospital, third hospital, in the chain of hospitals. So if all of those huge tables and their queries are working on just primary database, it's going to be overwhelming for that. So that's why when we create a table, we can actually connect that table to a helper database, and the benefit of that would be only when your helper database is on a second hard disk, which is that database will be using its own. So if we go to the second hard disk, do I have a second hard disk? Do we have a second hard disk on the first mem server? I think we messed up the second SQL server for that. Yeah, we just have one hard disk. So if I go to the second server and yeah, I haven't even configured the file streaming here. So I can still create file groups. So I'm just AdventureWorks. We have attached in the morning this new database that is a sample database from Microsoft. We downloaded that, and the link is there in the Google group. You can all download that AdventureWorks there, right? So if I right click here, properties, file groups. Oh yeah, I haven't given permission. So I have two drives here. I just wanted to, but we get the idea that because it's gonna take time now. So we get the idea that I wanted to give it a separate path. We can just give it a separate drive as well, where we can give a separate path, right? So let's just create a table now. So I'm just going to the food database and creating a table. This is a table. So right click, new table. So if you go to new table, hello, I create a new table. Yes, you. Sometimes when you talk like that, okay, it's still slow. Maybe you should not be mean. Okay, there you go. Okay, so new table is there. Okay, I want to see the properties of this table. So press F4 and the properties of the table will appear. So create a new table, or try to create a new table. We're not going to create a new table. We're just looking for the properties of a new table, right? So F4 is there. I want, suppose that second NDF file or the helper database is located on a second drive, which is SSD. And I want, this table will be very huge table. All hospital records, all the employees and patients, and daily rows and columns are adding. So thousands of queries are there. So that's why we purchased a SSD drive, and then we just placed specially that management NDF file in a separate SSD drive. Now I want to connect this huge table, suppose it was huge table, to that NDF file. How do I do that? So I go to the right side and go to regular data space, go to the file group, and here I can select that management. Suppose that management NDF file was on a SSD drive. This table would perform perfect without disturbing the primary database with all its own data to query, and its own without affecting its own performance, primary database performance. So if you place the NDF on the separate drive, now you can connect any new table to any of those. So if I just click this management, it's now connected to that NDF file that we could have placed easily on a SSD drive, right? So that's how we can separate the data. But if we don't do that, automatically it's connected to the main master database, primary database, right? If we don't do that, so it's connected to .mdf file. So we can change that to NDF and helper databases, which we can easily place on a separate drive. So file table connecting to that. So it's 9:54. It's break time, and then we have to go for other labs as well. So It's a break for those who came at 8 o'clock. Okay, so we're back from the break, and we were talking about the file group, the MDF file and the .ndf file, which are the helper database files, and to relieve the pressure of IOPS, or input output per second, from the master database. And we created file groups and then created files. The files actually let us put the path for the NDF database or the helper databases for the primary database, and we created all that. Then we created a table and tried to know if that table can be actually connected to the secondary databases or through the file group which we created, and we were able to connect the table to the secondary database or the .ndf. So when the data arrives in the food database, suppose if it is supposed to be retrieving something from this table and the table is connected to the NDF file, it's going to be using the input output or the hard disk or the IOPS for the second hard disk. This means the performance will be very good, because master database will not be touched if the table is not connected to the master database and is connected through the file group to the secondary helper databases, which may be on the second hard disk. Okay, so we did that, and moving an index from one file group to another as well. To move an index to a different file group or partition scheme. Okay, new terms here: partition scheme, file group. We know that we can create to distribute data between different files, .ndf files. We know the file group, but partition scheme also is just like a container where you can place the tables. But I'm going to show that in a little while. So in SQL Server Management Studio, perform the following steps. In SQL Server Management, we can indexes, index files, and the tables and indexes. There's a chapter coming for that. So still, some of the terminology will be different for us. So we can just go with the basic lab, or we can just go and try to understand how we move it. But what are they? How do we create it? That's coming in chapter actually 6 or 7. So just that what the book has discussed with shown, and we are going by the book, right? Face the book? No. Okay. Anyway, so you can move indexes under the following conditions, but index file is the file that helps search or make queries to the table that is connected to. So last time when we created a table, we created an index file as well, which we are not, we do not have to create for the AdventureWorks table or database that we created. If I go back to the server and go to that newly added sample database AdventureWorks here, and go to all the tables, so it has huge amount of tables there, and some of the tables have those PK database, log database. So it has the keys, and it has the index files and the columns that are related to indexing, which we will be actually learning and trying. We will know later that how to configure them. While our tables, if we create, they don't have that. That's why I had to import that AdventureWorks sample database from Microsoft. In fact, this could be used in the hands-on labs as well, so you have to attach that database. So have it downloaded before the test, and we're going to be since you're going to be creating the whole environment new, so you will have to ultimately attach that database and do some run some code on that as well, which I'll just provide in a Word file. Just show me all the results or save them, take a screenshot at that time. What I'm trying to say here is that index files are already created there, and later we're going to discuss how to create them and what kind of security measures we can take for those. but main database, we will try to work on AdventureWorks for the next labs because we just added and downloaded and attached it today. So let's go ahead a little and talk about. So you can move indexes under the following conditions. You cannot move indexes created using a unique or primary key. So I just shown you a file which is the primary key or unique or primary key. There are at least 7 or 8 types of index files. That's why it's big topic because you need to create index files for separate types of databases. There's a primary key constraint through SQL Server Management Studio. There's a contained database also coming right now, which we're going to be discussing. But these are some of the terminologies that are coming in the next chapters. In fact, maybe I should not have added that now because we're not talking in depth about that. You can move these indexes by using the create index statement. So when do we move the index file? Index file helps search in the table, right? If you don't have an index file, you cannot search in the table, right? So when you're moving a table from one file group to another, or you're creating a new table, so this is talking about moving. So if you already had a table that is connected to your master database, and now you see a performance drop, unacceptable performance drop, and you decide that, okay, I'm going to move the table from this file group MDF to the second file group, which I just created now on a second drive, SSD drive. So you have to move the indexes of that file, of that table as well, right? So that's what it's talking about right now, that you can have this create index command. You can use that to move the index as well as the table from one file group to another, right? So if the table or index is partitioned, you must select the partition scheme in which to move the index. Okay, partitioned. This is also coming. I don't know why the book uses a lot of terminology which is still coming. You can move clustered indexes by using online processes. Okay, clustered indexes, just leave it to the next chapter. In fact, I should just fly by because we're not talking in depth. So to move an index by using a statement, use the create index statement with the drop existing /on. If you want to, so just like you drop a table, you drop a database. When we talk about drop a table or drop a database, what do you mean by that? Does it delete that, or does it just detach that from that? So what do you say? What is drop actually doing? So last time we did delete it from when we talked about drop. But the files are always there. We can attach it again with another, with another database, with another instance for that. But it is effectively gone from some of the new terminology we just talked about. But I should not have even mentioned it because it's coming in depth in next slides, next classes actually. So configuring and standardizing databases. This is very important. You can standardize the configuration of databases by configuring appropriate settings such as auto close. So what was auto close? Anyone remembers that? Auto close. So auto close was that if you do not have any connections made by the users to your particular database, it's going to stop using memory and processor of that computer. It's going to auto close its services, and whenever there's a connection made at once, it's going to start using the CPU and memory. Pretty crazy, right? It has been not recommended by many database administrators that when it is dropping all the connections for CPU and memory, then it's taking up all the connections again. When it is taking up all the connections, it's using a lot of CPU and memory at that time. But the concept is auto close is that stop using your hardware resources, Mr. Database, if no connectivity is there, if you're not requested to do anything. Then do not just cling to your CPU just for running, right? Auto shrink, it shrinks what? Data. Okay, that's a good answer. So auto shrink, really it shrinks inside data, and well, it also creates free space called white space. This is the case for all the databases that, you know, the physical file size you would see 80 gigs, while the data inside is taking up only 60 gigs, maybe 70 gigabyte of data. So 10 gigabyte or 20 gigabyte, you may find out that it's just using up nothing. I mean, the files were scattered there, so the database size increased, but the files were defragmented, so the database size never decreased with it as well. So auto shrink tries to do that, but it is also, you know, doing some fragmentation where defragmentation where it's not supposed to. So it's also, you know, one of those features that you know, you will see, or you, if you start reading that 2016 SQL Server, you might not find it, or it will be improved or changed. Yes, this is one of those features that also is, you know, the administrators don't use a lot. Wow, features are written here and we don't use it, right? So, but it's 2012. Recommendations were made after testing these features, and in regular big environments, then it was, you know, recommended to Microsoft that could you improve that, or otherwise at least, you know, or just discontinue it. But there are other features which are very important. As you learned in chapter 2, the model system database serves as a template. Oh, I was going to ask that question. That's not fair. So, okay, what was the model system database doing? Okay, as a serve as a template for new databases that you create on an instance. We tried to open the model system database. The pictures here. For every database you create, there's always these databases created. One, master, second, model, third, MSDB, and fourth, tempdb. So we already know about master, that's the main database, file.mdf, then the model database. So it is all being used up for a sample, right? Or all the configurations, basic configurations are being picked up from these system databases, and they're performing all the system operations as well. So model database is for new database. It's a template for new databases. So if we go ahead, you can configure the properties of the model database either by using SQL Server Management Studio. Yeah, we did that. So let's go ahead. Understanding contained databases. Okay, this we didn't do. So contained databases include all the settings and metadata required to define the database. Okay, English please. Okay, so I'll explain it on the paintbrush as well. So contained databases have no configuration dependencies on the database engine, instance, that was same, on which the database is deployed. So users can connect to a contained database without authenticating at the database engine level. Anyone can grab something from this statement, like a database normally is turned on when the instance is on, and through the instance the database users can connect through the instance to the database. So what could be the contained database doing? The purpose. Anyone knows what this statement could say? So contained database do not need authentication from database engine. Contained database has no configuration dependencies. It's an independent database, and users can connect directly to it, and the database administrators can directly configure this database without going through the instance. Well, let's just see some more and try to do that. An advantage of contained database is that you can easily move them to other instances or to SQL Server 2012 Azure. Anyone knows what's Azure? Azure, okay. Azure is? Okay. So SQL Server, infrastructure as a service, and software as a service, and platform as a service. These are the three major stuff, and that covers everything actually. That it offers. It offers software that are available, databases that are pre-configured and available on Azure, on cloud platform. You just have to pay. You just have to have an internet connection and start paying, and you can start using the database. So we're going to be using Azure. In the end, I'm gonna try to at least go there to the Azure and configure databases and try to connect those databases to our on-premises databases. At least we're going to try to do that. So anyway, contained databases are independent databases which can be moved from one instance to another or to the SQL Server Azure platform. Let's just try to know more about that. Having all database configuration settings within the database enables the database owners to manage all those settings for the database. So the thing is that you can just directly configure that without touching the instance level settings, and it does not, any settings in this contained database does not affect the settings of the instances in any way. SQL Server 2012 supports contained databases and partially contained databases. Okay, there's another thing, partial CDBs, partial contained databases, which provide a high degree of isolation from the database engine instance, but are not fully contained. So again, any policies, any features you enable for the instance will not affect the contained database because it's contained. Okay, no, because it's not related to any instance. You can still create it inside an instance, but it's not going to take the orders of any instance. It's a I don't take orders from you, sir, kind of that database, right? So, okay, bad example. Anyway, so partial CDBs or contained database are transitional step toward contained databases. So partial means that some of the instance features it's going to take, some of the instance features it's not going to take. Pretty boring, right? Okay, SQL Server 2012 implementation of partial CDBs does not allow the following. Okay, seriously. Numbered procedures. We're going to try that. Schema-bound objects that depend on built-in functions. Okay, this is all non-English stuff. This is still upcoming. We're going to talk about schema. So binding change resulting from collation changes, including references. Let me just fly by from there. So because let's just try to do that to understand that. Replication, change data capture, and change tracking. Let's just go ahead. Okay, you can enable contained databases by using SQL Server Management Studio on the advanced page. So this is the lab we're going to be doing, and the code I'm putting on online now. We can convert a working database to a contained database, and a contained database back to a normal database. So on the advanced page of an instance's properties, by setting the enable contained database option to true, right? So this is the option in the advanced of any database that we can convert to. So you can enable contained databases by using, okay, first of all, we have to enable it on the server level. That do you want the contained databases to be configured inside the SQL Server? So to enable contained databases on an instance of SQL Server 2012 by using Transact SQL, issue the following query. So I'm just going to put that query up there on the cloud. No, it's not on the internet, that simple site. Okay. So what it's doing is it's enabling the contained database feature for our SQL Server. So I'm just putting up the code now and grab it from there. Let me know if there's an error coming. Okay, the code is there to enable the feature of contained database on our SQL Server. This enables the feature of contained database on our SQL Server. let me know if it gave any error. So I'm just gonna, I already copied that. So, okay, on the SQL Server level, new query. Okay, let me just go before and check what was the condition so I could just confirm that this command did that. So if I right click the SQL Server and go to advanced, so enable contain databases is false, or containment or enable contain databases feature for the whole SQL Server, it is right now false. If I right click the server and then advanced and then containment, right? So if I cancel it out from here and put this, okay, no errors so far. Okay, I mean like that wavy error thingy. Execute configuration option, contain databases change from 0 to 1. Run the reconfigure statement. Okay. So now I'm gonna check again. Right click, server, properties, advanced. Yeah, it has turned true. Although we could have just done this. Drop down. But anyway, since we are going all SQL statements, so we're just going to stick to that. So at least we have all the code there. Later we might need to run them remotely, so at least we have the code there. Okay, so it is enabled the contain databases feature there. Excuse me. All right, so to convert a database to a partial CDB, partial contained database or contained database by using SQL Server Management Studio, added the properties of a database and on the options page. So now we're going to go for options, and this is the property for the individual database. If you want to convert it to partial contained database, this means instance level features won't apply on those. And okay, on the options page, change the containment type option to partial or full. Actually, it's just for partial. So I'm just gonna go there and check. So properties. Oh, sorry. Where should I be going? Properties of what? Database, exactly. So databases, and then go for food. Why do I keep going on food? Anyway, so and go to options there. So there's that containment type. We can convert this database to a partial contained database so it's going to be more independently handled. It can be moved easily from one instance to another and to Windows Azure as well. But we're going to be doing it later. But right now we needed to just know where the options are and what does it do. Okay, since I'm doing all the experiments on food, anyway, press OK and partial just to check out if there are any errors or not. And there's an error. Oh, anyone else got that error? Got that error? Oh, anyone got that? Same? Okay. Alter failed for database food. Additional information. An exception occurred while executing a transaction. All database failed because a lock could not be placed on database food. Try again later. Okay, later. Define later. Okay, alter database still failed. Okay, what happened? Wow, that's a big one. For help. Oh, there's a link. Is it on? No, but everyone had that? Okay, we all did that, right? But it's still open. Okay. I thought I did it. But did it work?
Yeah, it works out.
Hey, you're a genius, man. So next class will be from Ryan He, and he'll be your teacher. And no, seriously, that's good. Thanks. And quick troubleshooting. That's one of the major qualities that in the job market they need. Maybe you're already doing a job. Okay, so it could not log it. So that's good. Thank you. Let's go ahead. We can change a database. So now we're going to be doing some more scripts on that, or commands on that, and let's see if the partial being that contained database, if it stops us or not. But let's just check about that. So what we have done so far, we can just we check that it's going to be, any database could be converted to a partial contained database. You can use the alter database statement with the set containment option to configure containment for a database after you have enabled containment at the database instance level. Okay, this is something we just did right now, but we can just check the code. For example, to set the containment of the food database to partial, although I put their food, AdventureWorks is there mentioned. What we since we have AdventureWorks also available, although those who did not download and attach it can go for this food database. So we just actually did it from graphical interface. So that's why I'm just going for the second database here, or if you have any other database, because on the server level we have enabled containment. So now we can just contain we contained from the graphical. Now we're going to go for the code, right? So that's why you should choose another database, because we already did the food database with the graphical interface. So there's that code. Just check if it works. It doesn't give any errors. It's going to be an asset for us to have it. So this changes a current database to be a partially contained database. Okay, so if we go there, and so I'm just going to try to enable the partial database containment feature on AdventureWorks, because I already done it on food by graphical interface. So going down, pasting this, I already have this AdventureWorks written here. Let me just check before doing this, the AdventureWorks. So if I right click the AdventureWorks properties and go for the options, it's showing none here. So if I just select it and go for execute, successfully done. So if I go back here to options, okay, it has changed to partial. So we can run this for remotely on other databases as well, or we can just mention multiple databases, and we can just try to put that. Okay, so let's go ahead and check the code. We check the code. So using data compression, row and page compression for tables. So what is compression? What is the difference between compression and encryption? They both have shun. Okay, so that's a similarity, right? So yeah. So compression is for security, and okay, I didn't even complete it. So, but anyway, it was obvious. So compression, yep. Do you need compression on? You created a table already. You know how a table is. So would you want to compress a table do you understand this concept of, this table is like employees, okay, there are 10,000 employees here, and there are all the information in the columns and all the rows is there, huge table. You want to compress that. Is it something understandable that we should do? Ever heard of that? Okay, that's a good one. Okay, no. So compression of, we can compress rows, right? We can compress even the rows by, there's three types of compressions coming. We can compress row and page compression for tables, and indexes enables you to save storage space by reducing the size of the database. Main thing, yes, save storage space, right? But how can you save storage, and does it affect your CPU and memory while doing that? Did you ever use compression on your disks? From within Windows, how can you compress your folder? You know that, right? Right click that, properties, advanced, compression, as well as encryption, right? Well, for the record of the video, if we go inside, okay, no, this, yeah, I was just becoming that. Okay, FSCRM, properties, advanced, and compress or encrypt. Yeah, you cannot just go with both. So it's going to compress this folder, but when you want to decompress it, it's going to take that CPU and memory to actually make it available for you, or decompress it and to copy it somewhere. So let's just talk about then how we can do compression on the databases. Excuse me. Oh. Okay, something stuck. Row and page compression. So let's try to find out what is it. Data compression has a drawback of increasing CPU usage. Obviously, whenever you compress something, you have to decompress it. Same for encryption, right? Same. CPU and memory will be used for decrypting as well. So compressing saves space, encrypting secures your data, but both take CPU usage. So this means your system is busy or much busier if you enable compression and encryption, which is the next topic for database. If you encrypt and compress it, wow, good luck. You must have a very high-end CPU. So drawback of increasing CPU usage, because the data must be compressed and decompressed when being accessed. You cannot use data compression with system tables. So there were system tables, just like they are created with the instance installed. There are system tables as well as system databases, and only the enterprise and developer editions of SQL Server 2012 support data compression. So this would be my favorite, one of the favorite quiz questions, but I just say it. Okay, you can configure data compression on the following. Cluster tables, okay, that's still upcoming. Heap tables, wow, what a name. A heap is a table without a clustered index. We're getting that. Non-clustered index. So what's clustered index? A cluster means that an exact same copy of either a table or either a database, and if one is for load balancing, but mainly when you talk about clusters, it's all about high availability. If one goes down, the second one is used, right? Cluster is specially used for high availability. But when you have twos of something, there could be either active or passive, or there could be active-active. If it's active-active, then it's load balancing as well as high availability. If it's active-passive, then the active one is working in standby, is just waiting for the active to go down. So indexed views. Okay. So compression, you can configure data compression on the following. Yeah, all these. So any search file, the file or index file, you can use the compression. You can make the size smaller. When you run queries, okay, I want to find the employee, this employee, and the pay, whose pay is like 1 million or more. Hey, there is one person here in Toronto who receives, not one, at least more than 10 who receive a monthly. Okay, not monthly. That's just too crazy. Yearly, 1 million. Police chief. Oh, I'll edit this. Okay, individual partitions of a partitioned table or index. So we can just compress all these. But main thing is, okay, what is row level compression? It works by using more efficient storage formats for fixed length data. Did we talk about fixed length and variable length in the start? There were two types of ways we can put the characters or input, take the input. There was varchar and something else char. Regular?
No, not regular.
The characters. What was the difference? Excuse me. Exactly. So either dynamic or fixed character length. So, oh, that's going to get just 2 characters. So when you want to type the third one, it won't take that input. So it can effectively work on, so row level compression uses the following strategies. So using more efficient storage formats for fixed length data. If you put it on dynamic, then it's gonna use less. Row level compression uses storing fixed length numeric data types and char data types as though they were variable. Yes, that as I was saying, that changes to dynamic, and you will have, suppose if you put it 10 characters has to be space there, but actually you're putting input is less characters, so it's going to convert it to dynamic, and it's going to take away that space which the fixed length was using, and it was not actually used for input data. So not storing null or 0 values. Okay, we can do the compression, but we're going to be talking about when indexing is there. We're going to talk about that. Reducing metadata required to store data. So what's a metadata? Anyone knows what's a metadata? I'm still, yeah, you're right. Okay. So required to store data. So the information required to store data means where is data across the table, across the volumes, columns and rows. So it's that data, and that data has to be compressed as well. If the table is very huge, thousands of rows and columns, and it has to retrieve information, collect information, and make searches for thousands of users at the same time. So indexing works a lot, and metadata is used at which file is where. So although it does reduce the amount of space that data uses, row level compression does not provide the storage improvements of page level compression, right? So page, anyone knows page? No, that's not some, page. Okay, anyway. So page is the, yeah, you're right, exactly. Page is a unit of, is the smallest unit of instance. Okay, let's Google it and find out what is page, because on the day one we discussed about that. Okay, page level compression is coming. We're going to talk about that. So page level compression, the advantage of row level compression is that it requires less CPU, really, users than page level compression. Okay, let's see. When we talk about page level, you use the following syntax to compress a table by using row level compression. So there is a code even for that. Alter table. So we have been using alter database command till now, alter instance, but now alter table. Table name rebuild with data compression row. You want to compress a table now? What do we need to change here? What is the only thing we need to change here? And do we have that right now in this code? Which is, do you have any? So if I just put that code there, and then let's see if it gives successful or it gives an error. So I'm just going to put that there. What we're doing is try to compress try to do a row level compression by running this on our table. So this is the query here. Try to run against our table, and it's a row level compression to be run against current table. Okay, so let's just put that there. Go back to, so do we have a table? Well, here we are, AdventureWorks, we have a huge amount of tables, but if we go for food, I created employees. We had an employees table, right? So if we go there, and I will just make sure that I'm on this database, food, because it's showing here, and put that there. Table name is this, employees. Let's see if it gives that red wave. That means error. Well, it did not. Did it just process the information? Okay, command completed successfully. I will want to know if where do we go and know that, hey, it has compressed that, other than trying to check the overall size, which we won't do. If it says that compression is enabled, or permission, no, change tracking, false, any indication, okay, compression type row, there you go, here in storage. Okay, if I go to another table, it should not automatically say that, or maybe by default it is. So I'm just going to check another table here. To lunch, I have created a table here. Yeah, there are GB students under the lunch database. If I go to properties of this table and go to storage, yeah, compression type none. So now we know that command we ran actually enabled in the storage, it enabled the compression type as row. So row level compression, it takes less CPU, and we have to run it against any table. We haven't done or started running codes on multiple stuff. So employees. Okay, so let's go ahead and try to know the next one. This code works. Anyone got the error for this? Again, running against any table? Nope. Nope. Okay. You ran? Okay. Okay. You were like kind of sure, not sure. So okay. Thanks. All these long list of codes, expect majority of them in the labs. Since you already successfully ran it, you have the video with that. The only thing would be, did you configure your basic environment correctly so these codes could run correctly on that environment, right? They're expecting all the services to be running these codes and everything else to be running. So if you configure it best in your midterm, in your hands-on test, these all scripts will run fine. So although it's been easy till now, once we get down to always on and high availability, it's gonna start getting really tough. So for example, to rebuild all partitions of the sales.customer table of the AdventureWorks 2012 database by using row compression, use the following query. Although we just used it, those who have AdventureWorks downloaded and attached already from the Google group link that I sent, I'm just putting that there. So there's a table inside this database called sales.customer, and it's going to do a row level compression on that. So I'm just putting that up there, but I'm just going to go ahead. So you can take it from there because we all have AdventureWorks. Database. So row level compression for this table. Okay. Well, all it needs is we just need to run it, right? Okay, can't help it. Let's just run it. So I'm just gonna go for AdventureWorks, and all these tables are there. If I just get down here, and first of all, I need to make sure that AdventureWorks is selected up there, and then if I just put that whole statement here, so AdventureWorks, all to tables, sales.customer, there has to be a table called sales.customer. If I go way down, there's that sales.customer. And if I just go right click and properties, of course, to the storage, its compression is none, and just let's run it on this sample database. Yep, it works. And right click properties, we just repeated the same thing, and it's row level compression enabled now. Okay, so this code also works, right? Okay, Unicode compression. Unicode enables the database engine to compress Unicode values stored in page or row compressed objects. You can use Unicode compression with the fixed length n character, or any number of, or NVAR, or variable characters. So still the same, fixed space and the variable space. Data types. Unicode compression is automatically used where appropriate when you enable row and page compression. So if we enable row compression, this Unicode compression for Unicode characters will automatically be used, right? So we need to still decide why would we use compression, and we must have a good reason to do that. Otherwise, it's more performance. You're hitting the performance when you're enabling the compression. Page level compression compresses data by storing repeating values and common prefixes only once, and then making references to those values from other locations within the table. So there is, anyone ever heard of Windows 2012 technology called feature called deduplication, data deduplication? Anyone ever used it? Data deduplication, or the concept is exactly the same? Wow, nobody told me that. You cannot see that, right?
No.
Oh, it just happened. Okay. So I was like, huh? And what? Sorry. So yeah, data deduplication, exactly same concept. What same concept? The data, same data. Suppose you have that Kung Fu Panda 2 movie. 5 times you copied in your 4 terabyte drive in different folders, and you enabled data deduplication on that disk. So what happens is that it's going to delete from 4 places, 3 places it's going to delete, and it's going to create that pointer on those places where it deleted that file and pointed to that one place where that movie file is. So whenever you go to that other folder, it will look like that movie file is there actually. When double click, it's going to just redirect to that one place where that movie file is left. So you save, suppose it was 2 gigs of file, 3 gigs of file. So you save 6 gigs if it's 2 gigs file, just by enabling that data deduplication feature in 2012. I think in 2008 as well it's there. Yeah, but not 2003. So this is the same here. Page level compression compresses data by storing repeating values. So whatever values are repeating and common prefixes only once, and then making references to those values. So whatever is repeating, it's going to remove that, and that space will be saved, and it will just refer to that character or prefix or value in some other place. when page compression is applied to a table, row compression techniques are also applied. So already, seriously. Page level compression uses the following strategies. So row level compression is applied to maximize the number of rows stored on a page. Column prefix compression is applied by replacing repeating data. Patterns. So page level compression is all about that whatever is repeating, and it's going to check for the patterns there, and it's going to create references of whatever is duplicated or being repeated there. This data is stored in the page header. Dictionary compression scans for repeating values. You know, there's another term called dictionary attack. You know what's that? That's a very common brute forcing. Dictionary attack. What does it do? If you know, what's the concept behind that? Dictionary attack. It tries to guess from a dictionary your password. So here's 1, 2, 3, and the dictionary has all the common wordings, huge amount of wordings, combinations of letters, commonly used passwords. So if it's 1, 2, 3 at once, your password is cracked, right? So, and the user could be sitting on internet anywhere. If your emails have, of course, easy, the dictionary attack could be put against your whatever has the credentials, and it can just guess the password from dictionary, look up the dictionary, and it could be this, could be this, could be this. And it's a huge number. So always try to change your password every 30 days. So dictionary compression scans for repeating values. So it just goes through and scans the repeating values and then stores this information in the page header, just to know that what values are being repeated, and then make a reference of that value and delete it from if it's repeating so much. The benefits of page compression depend on the type of data compressed. Data that involves many repeating values will be more compressed than data populated by more unique values. Wow, that's a complicated statement. Okay. So it is all about what is repeating. If there are unique values more, then page compression is not useful, right? If there are unique values, right? If there are repeating values, then only it is. So how would you know that there are so many repeating values? Depends on the type of data. For example, any other example? Yep, exactly this. So definitely, page compression, we would not go for that if it is not useful, right? So we should decide before enabling any kind of compression, because it's a performance hit and it's pressure on CPU. You use the following general syntax to apply page level compression. Okay, we'll just I'll just put it there, this table, and just check if it makes any change. Of course it's gonna work, but when we make it work, then we really know. So I'm just putting I put that code there, and it's page level compression. So the only thing that changed was data compression equals row, data compression equals page. Anything other than that is exactly the same. So I'm just gonna put it back there just for the video, and go way down. I'm still working. Okay, so first this adventure works. I put so I can just take that sales.customer data, that table, alter table. So I'm just gonna copy that sales.customer from here and change from row level to page level, right? Row level to page level. And why did it go? Okay, word. Okay. So, and if I run it now, so I already checked that sales.customer was turned to row. Now it should turn to page level, right? So when I go and check the sales.customer and storage, yeah, it's page now. Okay, no one got an error, right? Everyone who is trying and no one got the error. Okay, like lots of errors. Okay, huh? What are you trying, man? So, for example, to rebuild all partitions. Oh, seriously? Now we're not gonna try that. So this is just for page compression. Encrypting databases with transparent data encryption. So both will have performance impact. We know that compression we can do on row level, page level, but we can also encrypt the database, right? So transparent data encryption (TDE) enables you to encrypt an entire database. Oh, seriously? Let's try that. So TDE or transparent data encryption protects the database against unauthorized third parties gaining access to the hard disks or backups on which the database is stored. So if I just encrypt the database, so suppose you want to delete the database. You don't want to take away the data. You want to delete the database. Can you delete an encrypted database? Did I ask that before? No. Can you delete an encrypted database? Anyone knows that? Can the encryption stop us from deleting a database if we encrypt it? No. So definitely encryption is just to scramble the words so they are not understandable, but it cannot stop us from deleting it. We have to put the permissions, right? So TD encrypts, or transparent data encryption, encrypts the database by using a database encryption key that is stored in the database boot record. It has that multiple steps to secure a database. There's a code that just starts encrypting it. So the database encryption key DEK. Database encryption key is in turn protected by the database master key, and database master key is in turn protected by the service master key. So there are three keys which protect each other once you enable encryption. And you can use BitLocker drive encryption, a full volume encryption method supported by 2008, 2008R2 and 2012 and 2016, of course. Although this will not ensure that database backups are encrypted. So you can encrypt the drive, whole drive. You can encrypt that by using the BitLocker service. And you can just do not encrypt the drive, but encrypt the database only by creating the 3-level keys and then protecting the last key. Oh, seriously? Okay, so I put the whole lab in this notes area because it's going to create the master key and then the server key and then the key, and then it's going to encrypt that. And then we need a proof as well. So putting that up there to the cloud, that's a big one. So how to encrypt a database? How to database, and the code is, here goes nothing. Whoa, the whole page. What if you want to, we can just do it very quickly by just running those 3 codes, and it's going to work. It's if we have the proper editing or customization. So the first step is create the master encryption key. Then the second step is create the certificate protected by the master key. Third thing is create a database encryption key and protect it by using the certificate. Fourth is then encrypt the database. Wow. So first is create a master key. Then after you've created the master key, encryption key, the next step involves creating the certificate that will be used to encrypt the database. Okay, we can create that by using the create certificate command. So create certificate, server certificate, still that uses subject name server certificate. Okay, we still don't have to customize for the two. Third one is in AdventureWorks, which is our database. Create database encryption key. That's where we will be implementing the encryption. Actually, we're going to turn it on the fourth command, but the third command is just to still enable the encryption on AdventureWorks database. We need to have a safe way out as well, so let's not use the AdventureWorks because it's a big database, or you may have to delete it later if we somehow messed up the keys and we want to do some other lab. So I'm just gonna quickly run this on my other databases, lunch database or food database. So I'm just gonna run the first code here to encrypt the full database, to create the master key, then the certificate, and then the database encryption key. So the 4 steps. Let's just try that. So I'm just gonna, now I need to create a new query. Anyone trying this encryption key? That's good. So paste. So first we are creating a master key. We're going to encryption by password, and then master key password here. So I'm just gonna put the password here as the class lab password. ABC, shift ABC, and do not try to use it for your emails, or at least let me know. Oh, don't let me know. Okay, so execute that. So the key has been created. This is the perfect time to actually, or perfect lab to actually test the whole code, because then we have that confidence that we ran it and it's really working, and the codes will come in the exam as an exam objective. So first we have done the create the master key, then we are creating a server certificate that uses the subject name server certificate. Use the following query. So okay, I'm using the second code now to create a server certificate with subject server certificate. Okay, execute. Okay, so I'm just going for the third one now. After you have created the master encryption key, the next is certificate. After you have created this, you can create the database encryption key, or DEK, for the specific database. Now we need to mention the specific database. So you do this by using create database encryption key statement for example, for AdventureWorks. Instead of AdventureWorks, you go ahead and do if you want to do that. I'm just going to change my database name here using the third code now. So I'm just going to go for the other database called lunch. Let's mess up this one. So I need to make sure that I'm in the lunch database. Okay, up there I'm just going to choose the lunch database, so it will just encrypt this one and change the name. Sorry? Yeah. So use lunch, go create database encryption key with algorithm AES 128, encryption by server certificate, go. Okay, seems fine. Make sure on the top the actual database is selected here on the top, right? So go ahead, execute. Warning, the certificate used for encrypting the database encryption key has not been backed up. Yeah, whatever. Tell me if it worked. Yeah, it worked actually. You should immediately back up the certificate and the private key associated with the certificate if the certificate ever becomes unavailable, or if you must restore or attach the database on another server. you must have backups of both the certificate and the private key, or you will not be able to open the database. So definitely we have to secure that server certificate and the key and for the password. Let me check how to. Now we need to enable the encryption, and hopefully we would want to have a proof that was the encryption enabled or not. So again, I'll change the database name here. The last query I'm running now, all three were fine. So okay, keep going down. Okay, just change the database to, in my case, lunch database, and I hope it does not give me any error. Okay, so the lunch database should be encrypted now, and I want to know if it happened. So if I right click the lunch database and properties, if I go to general, hey, does your database show anywhere that encryption is enabled? Options, containment, cursor, FileStream, miscellaneous, arithmetic, date, correlation.
Oh, in options, go over to the bottom. See encryption enabled.
Hey, cool. Thanks, man. All right, that was fast. Okay, encryption enabled, true. So we should have gone here first and checked, but we can just check any other database, and definitely this is the area. Encryption enabled, true. Okay, I can go to another database just to make sure, just like last time I made sure. So options, go way down, and yeah, encryption is false here, right? And all we needed to do was in the graphical interface this, but this is after doing those key steps, right? The creating the master key, then saving the certificate, then enable only this one, right? So it really worked fine with all those codes, and this database is supposed to be encrypted now, and it is. Options, go way down. Yeah, it's true. But you know, the proper steps have to be done, then we can just turn it to true instead of false. Okay, good. No one got any error, right? Straightforward, right? Okay. So let's go. So compression, then encryption, then shun. Okay, no shuns. Oh, lunch. When I say that, so partitioning indexes and tables. Seriously? Okay. Partitioning index divides index and table data across more than one file group. We did try to do the data division, or by dividing the data into file groups. We created NDF files, or the helper database files or secondary database files. So partitioning divides index and table data across more than one file group. Data is partitioned so that groups of rows are mapped to individual partitions. Okay, that goes a little too. So all partitions of a table or index must reside in the same database. Okay, you can use partitioned indexes and tables only in the enterprise. Hey, can we do that instead of? Okay, you can use partitioned indexes and tables only in the enterprise. Okay, these additions is going to be working. The x64 versions of SQL Server 2012 support up to 15,000 partitions. It is possible to create more than 1,000 partitions on the x86. Yeah. Okay. Oh, seriously? Table and index partitioning involves the following concepts. So this is the last of today, and I need to include the lab for that. So this is, oh, we finished early. That's not fair. The slide is end. This is the end of the slide. So we will start doing something else, and that's it. Let's go home. No, there was a long lab which we have to do it next time because there is a script that I need to do for the file streaming, and there's this has a long lab, and without lab we won't be able to understand this partitioning indexes. So these two are due on me, and there are long list of topics, but now I'm going to really go a little faster to cover the most critical topics because of we need to do the always on and other high availability topics as well. Yep.
Sorry, because we don't have a class next week, are you still going to upload a video? Because otherwise, how are you going to make up that class?
That's family day, right?
Yeah.
So it's a day for the family, right?
I mean, you could do it another day. But
Yeah, we can do that. When? Any votes? Oops, let me just